Polymer and polymerization. Toys, which are these are plastic toys. Basically, these are polymers, polymer products. There are many other things we use in our daily life. Polymer products. What is polymerization? Polymerization is the chemical process to form giant molecules by joining a large number of small molecules. The giant molecules which are formed known as polymer and the small molecules which join together are known as monomers. The tiny monomers are too small to see separately, but the polymers are very big and very useful. These are raw polymer. If you magnify a small piece, you will get many small molecules joined together in the chain to give the giant structure. Polymer has types. We get two types of polymers: addition polymers, condensation polymers. First, the addition polymers. Some separate small molecules are monomers and they join together to form a single big molecule, which is the polymer. The monomers join together to form the polymer without anything else as byproduct. Thus you get one thing, nothing else as byproduct. Condensation polymers. You get here few small molecules. They join together to give a bigger molecule, big molecule. This is polymer. And water forms there as byproducts. So in this type of polymer, the monomers join together to form the polymer, the big one, with byproduct. Water is here byproduct. Monomers of addition polymers and monomers of condensation polymers. Comparing separate small molecules and separate small molecules. The monomers are unsaturated, having double bond, carbon-carbon double bond. And here you get each of the monomers has bifunctional groups. And you certainly see here the first one with two carboxylic group, second one here with two OH, two all. So these are bifunctional groups. And then monomers are usually single type. If you look at the monomers of addition polymers, you see all four are same. I mean single type. But are the monomers of condensation polymers same? No. There are two types. And now we see how the monomers join in addition polymers. Look, the double bond breaks down to form single bond and the broken bond spread around the carbon-carbon bond. And same thing happens to the other molecule. And then two molecules join together to give a bigger single molecule. And get a bigger example with four monomers. The first one break down to form single bond and extra bond. This is a repeat unit. The second monomer doing same thing, this breaking double bond and form second repeat unit. This is how all of them break the double bond and make extra bond which hold the adjacent molecules and form bigger molecules. We can write this four repeat units together as you just write the repeat unit once and put a bracket crossing the bonds and give the number 4 here. But if the number is 4, we write the equation as, and number may be different. Suppose this is n, and you will get the polymer with n repeat unit. This part, the middle portion, is here repeat unit. More examples of addition polymers. Ethene, polyethene. Just breaking double bond, you put a bracket crossing their bonds and n number here. Chloroethene, same, polychloroethene is name. Propene, can you draw the polymer and name? Yes, polypropene would be there. And exercise, you try yourself. Butene here. Propanol. Drawing technique. This is with the structural formula, and you may write this mistakenly. This is wrong because the double bond has gone to other atoms. The double bonds were between carbon atoms, and after one of them has been broken, that moved to hydrogen atoms. This is not wrong. Actually, this should be here this. So after you break the double bond, the broken bond still belong to the carbon atoms. How you can draw? How should you draw? Before you draw the polymer, first arrange the monomers. Arrange the monomers such a way that other than the carbon-carbon double bonds, the other atoms or other groups should be below and above the bonds, the carbon-carbon bonds, keeping the left and right side empty so that can spread the bonds. This is right. Another, this is prop 1-ene or propene. Is this correct? No. Look at the blue color. That was between carbon atoms, now given to another carbon atom. So how should you do this? Just put the carbon-carbon double bond in the middle and other atoms or other groups below and above the double bond. And now you can draw easily. So have some exercise. Similarly, the first one, second one, third one, fourth one, and fifth. If you are able to draw them perfectly, then this exercise is very good and this lesson is complete. So now we move to the condensation polymers. Here 4 separate molecules. 2 of them are same and 2 other are also same. So there are 2 types. They join together to give the bigger one is polymer and byproduct water. You already got this. The monomers join together to form polymer with byproduct water here. And condensation reaction. This is dicarboxylic acid. On both sides you get carboxylic COOH functional group. And this is diol. On both sides you get OH and OH. Actually we are writing here 2, giving here 2 as an examples, but there are just 2 types, not 2. There are many thousands of them are there, but there's 2 types. And to make the polymer or in the reaction, the carboxylic acid, the diacid will lose OH from both sides, and all the diol will lose H hydrogen from both sides. And there are many, so here given few more. All the dicarboxylic acid will lose OH, and all the hydrogen diol will lose hydrogen H. And let's see, they make water after they're lost, and then they join together because they got their empty hand, empty bond. This is the big one, a condensation polymer, and water forms there as byproducts. Look, this is repeat unit here because this is common frequently in the long chain, and you can write the polymer just writing the repeat unit once, and must give a bracket crossing the bond and N. Polymerization. Condensation polymer. Again, get example. Here is dicarboxylic acid and here is diol. Equation. After the dicarboxylic acid lose OH from both sides, the remaining portion would be CO, the middle portion CO, then O, CH2, CH2O, and bracket and N. Water forms as byproduct. The middle portion of the polymer is a COO. This is an ester functional group. It's called here ester link. Thus, the polymer is a polyester because that contains ester link. Get another example. Diacid, dicarboxylic acid here, and diol. Can you write the polymer? Simple. The diacid, from the diacid just cross out OH, and from the diol cross out H. They will make water, and the remaining part will be together just with N and bracket. Water here byproduct. If the middle portion is CH2 and CH2 for both diacid and diol, in the polymer you will get same. Actually, the middle portion remain unchanged. Get another example with middle portion 2CH2 dicarboxylic acid and 2CH2 as carbon chain in the middle for the diol, the polyester, just omitting OH from diacid and H from diol. Water here byproduct. Polyamide here. In polyamide we get dicarboxylic acid and not diol. This is diamine. NH2 is amine. 2NH2 on both sides is diamine. What would happen? Similar. Just cross out OH from the dicarboxylic acid and H from the diamine. The remaining portion will be as this. Repeat unit, bracket and N, polymer, and water would be the byproduct. Here you get again the OH has been lost from both sides of the dicarboxylic acid, and H has been lost from both sides of the diamine, and you get the middle portion CONH, amide link. It's an amide functional group. So the polymer is polyamide. Get an example here, diacid with any unknown number of or any number of middle portion carbon chain, and here you get diamide what would happen? Simple. The diacid will lose weights on both sides and the diamine will lose H from both sides. Water as byproduct. If the middle portion is CH2, then the product will contain CH2. We basically don't work with the middle portion. We just keep them whatever they are. Get another example, diacid with double CH2 in the middle and single CH2 in the middle of the diamine. What would happen? Can you draw yourself? Simple. And this time you get some exercise. Draw polymers from the following monomers. You get 1, 2. These are monomers of condensation polymers. And first one is diol, second one is diacid. So with diol and diacid you will get polyester. The second one is first one dicarboxylic acid and second one is diamine. So with them you will make polyamide. Both are condensation polymers. And next, a reverse practice. Draw monomers involved in the following polymers. I mean these 4, 1, 2, 3, 4 are given polymers. With the polymers, you need to extract the monomers. Draw the monomers which have been involved to make the polymers 1 to 4.